The solution to a system of equations is the what? The point of intersection. Everybody by this point should be able to say that. Just because you might not want to speak out, you better know it. You better have that written down. Now, what gives us a solution to the system? Slope does. Okay? The rate of change. My man's back there. He's back, ladies and gentlemen. So, all right. So we're going to work this three ways. We have a system. We know a system exists when I have two variables and I have two equations. If I have one or more equations, I have a system. Okay, when you move into Algebra 2, we're going to have three of these. So we'll have three equations to make a system. All right, so I'm going to work this three ways. Now, the first way is going to be like if I was taking this on my own and I looked at the characteristics of the problem and I'm going to decide based on it, this way would be the best. So if I look at this, I see that they're both in standard form. I don't have to do any moving about. And I also see that I have a coefficient of 1 in two places, actually. And so with that, elimination is my best way, or my most efficient way, because coefficient of 1, both in standard form, doesn't have a whole lot I have to do to solve this. Okay? And so, with elimination, okay, we're going to solve it by that. So I'm going to take my original equation, and the variable that I'm going to eliminate is going to be the y. Why would I choose that one? Is because it's a coefficient of -1. So I have to just multiply through by one single number and then I can eliminate it. So I'm not messing with the top equation. The bottom equation, I am going to take it and I'm going to multiply -1 to it. So I take this equation here. I'm going to multiply by 2, so it'll eliminate my y. So again, didn't mess with my top equation. My bottom equation is going to become 2x minus 2y equals 26. I add those. This becomes 6x. This becomes cancel out or eliminate from my y equals 36. Divide by 6. X is going to equal 6. Okay, and now from there I have a value for x. I can substitute it in anywhere I want for x and solve for y. -16? No. What do we get? 10 minus 24? -14. Divide by 2. Y is going to equal -7. So what's the solution to my system of equations? Why do we know that? Because it is the what? Say it. Say it with some gusto. Point of intersection. It's the point of intersection. Now, I'm going to also solve this the other ways because you might not have used elimination. So I'm going to solve it in all of them, so therefore you can see your way. It's not that you've got to be able to do them all. It'd be nice. That's the goal. But you need to be able to at least be efficient in one way. Okay? And so we're going to use substitution now. I could use a substitution, but I'm going to have to do a little bit of work. Okay, I'm not going to try to do anything to my top equation because there's a lot of moving parts right there. So I'm going to keep it. My bottom one, if I move the y over, or if I move the x over, I would move the y because if I move the x, then I'm going to have to divide by -1 because I can't have a negative y and substitute. So I'm going to move the x over. And so when I do that, stupid. Just said I wasn't going to do that. Move the y over. So I'll have x by itself. Have y plus 13 is what x equals. Now I can substitute that. Wherever x is, I can substitute in y plus 13. What is that? 52? 4 times 13, 52? Thank you. Okay. That equals 10. So we have 6y plus 52 equal to 10. Subtract 52 from both sides. 6y equals negative 42. Y is going to equal negative 7. Okay? And so I'm going to substitute that one into this equation here for y. That negative and that negative, which is a skill that we struggle with recognizing, that minus negative 7 makes that a positive. It's like a negative 1 times a negative 7 makes it a positive. It's a skill we struggle with. And there we go. Same answer. All right. Now the last way to do the problem is graphing, which is the one most of us will choose because it was the first one that we learned. And the calculator is going to do the work of calculations for us. However, the skill that we struggle with the most is getting this in proper notation to graph by. That's something we work with. And it's going to require a lot for both of these equations to do so. So for the first equation, because both of them are in standard form, so some changes have to happen to get it into y equals mx plus b form. And so therefore, I have to solve for y is my terminology. So I'm going to subtract the 4x. 2y equals negative 4x plus 10. One common mistake that you make when all of you did this on the test is you didn't divide everything by the number on the y. You just divided the part on the x. Have to divide everything. And so I'm left with negative 2x plus 5. So that's my first equation. This is the one that I'm going to use to graph by. Okay? The second one is a little bit easier to do because there's no coefficients but 1 on the x and the y. So I got to move the x. I saw a lot of issues as well. You would do the very first step of any of these correct, but when you move down to here, like I subtracted this x, and then I moved down to changing it, you would forget signs. You would leave signs directly off of them. And whether it's just paying attention or not knowing they need to come, that was one thing that I noticed on a lot of your work is, let's say you did this correct. That's a proper move, is subtracting the x. But when it came down to here, you didn't bring the sign of the negative with it. You just left it off. Okay? And so we got to divide everything by negative 1. So I have y equals x over 1, or just x minus 13. All right? And so now I have my two equations that I'm going to graph. I have the broke calculator. All right? And so on here, my y1 is going to be negative 2x plus 5. My y2 is going to be x minus 13. I'm going to hit graph. Can you see the point of intersection? Most certainly. So therefore, I'm going to go second calc, go down to intersection. And the next thing is I got to make sure that my little blinky thingies are on the opposite sides of the point of intersection, and therefore you can see that it is 6 and negative 7. Now, this one's very evident of what the solution to a system is because you can see the point of intersection. Now, are the slopes of these two things the same? Are the slopes the same? One of them's negative 2 and one of them's 1. So therefore, if I have different slopes, I will have a solution. Okay? And therefore, my answer is 6, -7.